Deep under the border between France and Switzerland, engineers are making the finishing touches to a giant machine that promises to change our understanding of physics. On September the 10th, the Large Hadron Collider, or LHC, will be switched on, and the first beam of protons will spin around a 27-kilometre ring. Protons start life above ground as hydrogen gas atoms. They are stripped of their electrons and are injected into a succession of rings where they gather speed and gain energy. Eventually, nearly 3,000 bunches of protons, each containing 100 billion particles, will be injected into the LHC. The protons will circulate in a vacuum tube and will be steered around the 27-kilometre course by over 9,000 magnets. Superconducting devices called cavities will accelerate the protons for about 20 minutes until they reach 99.9999991% the speed of light. Beams of protons will be accelerated in opposite directions and smashed together at 4 sites where detectors have been placed. Our first stop is at ATLAS, the biggest detector ever built in a particle collider. It's about half as big as Notre Dame Cathedral in Paris and weighs as much as the Eiffel Tower. It's designed to track collisions between very high energy protons, which will occur in the middle of the instrument. Physicists will be able to obtain a huge amount of data from the collisions, enough to fill 100,000 CDs per second. But they'll only record information that could lead to new physics, which is a fraction of the data available. ATLAS will attempt to find out more about the basic forces that formed our universe. Physicists will be investigating the origin of mass, extra dimensions, and perhaps even tiny black holes. Next stop, CMS, or Compact Muon Solenoid. This detector is similar in design to ATLAS, though it uses different technologies. CMS is extremely compact considering its enormous weight. Most of that weight is down to its powerful superconducting magnet that bends particles and helps to identify them. Both the CMS and ATLAS detectors are built like an onion, and each layer in the instrument measures different particle properties as a collision takes place. Like ATLAS, this detector could provide answers to profound questions, like what the universe is made of and what forces act within it. Now we take a look at the LHCb, or Large Hadron Collider Beauty Experiment. It is specially designed to investigate why matter triumphed over antimatter in the early universe. The experiment is designed to look for particles called B mesons that could reveal important clues about the nature of antimatter. The first important physics results from the LHC could come from the LHCb detector. Last stop, ALICE, or a Large Ion Collider Experiment. Experiments at this detector will be trying to find out what happens to matter when it's heated to temperatures 100,000 times that of our Sun. They'll try to figure out why protons and neutrons weigh 100 times more than the quarks they are made of, and if it's possible for quarks to exist on their own, as they've never been observed in isolation. Physicists hope the LHC experiments will finally uncover the Higgs boson, popularly known as the God particle. They also hope to find out what makes up the invisible dark matter that fills the universe, and if theories about extra dimensions, superstrings and gravity are really true. It's all uncharted territory though, so no one knows for sure what might turn up. But whatever the LHC does find, physics and cosmology are in for plenty of excitement over the next few years.